Good morning. Today we are going to see about Bernoulli's theorem. Bernoulli's theorem statement: the total energy of an incompressible non-viscous liquid flowing from one point to another without any friction remains constant throughout the motion. This is the statement of Bernoulli's theorem. That is, once again I repeat it. Bernoulli's theorem: the total energy of an incompressible non-viscous fluid flowing from one point to another without any friction remains constant throughout the motion. Explanation: according to this theorem, the sum of kinetic potential and pressure energy of any element of an incompressible fluid in a streamline flow remains constant. For that we have to take one pipeline. So the height of the particular element fluid of density rho above the ground level is height. Let moving with the velocity v. Now we are having the pressure at the particular point B, then its total energy per unit volume is E is equal to rho v square by 2 plus rho gh plus B. Then Bernoulli's theorem states that E is a constant one. If the 2 points in the fluid, the velocities are v1, v2 and heights of the liquid is h1 and h2 and the pressures are p1 and p2. Then rho v1 square by 2 plus rho gh1 plus p1 is equal to rho v2 square by 2 plus rho gh2 plus b2. The kinetic energy per unit weight is called velocity head and it is equal to v square by 2g. The potential energy per unit weight is called the gravitational head and it is equal to h. The pressure energy per unit weight is called the pressure head and it is equal to p by rho g. Bernoulli's equation can be written as v square by 2g plus h plus p divided by rho into g. That must be a constant one. Then the velocity head, total energy, here the total energy is velocity head plus gravitational head plus pressure head is equal to a constant. So in the case of a fluid flowing along a horizontal pipe, the gravitational head h is a constant one. Now the equation, above equation is v square by 2g plus p by rho g is equal to constant, or I can write v square by 2 plus p by rho is equal to constant. So finally, I can write p plus rho v square by 2 is a constant one. That is, static pressure plus dynamic pressure is equal to constant. So now we are going to prove this Bernoulli's theorem. Proof: consider a fluid in a streamline motion along a non-uniform tube. It was given in the figure. Then let A and B be the two sections of the tube at heights h1 and h2 from a reference plane. Let A1 and A2 be the cross-sectional area of A and B. Let V1 and V2 be the velocities of the fluid at A and B. Let P1 and P2 be the pressure at a particular point A and B. Since A1 is greater than A2 and V2 is greater than V1, hence the fluid is accelerated and flows from A to B. Now we are going to calculate the work done per second. The fluid, that means the liquid entering at A is W1. Now we are going to calculate both the points, that is A and B. The work done is calculated at the both points. So first we are calculating the work done at a point A. For that I had to write the work done W1. So W1 is equal to force at A into distance moved by the liquid in 1 second. So the equation is P1 A1 into V1. Finally, I can write W1 is equal to P1 A1 and V1. Work done per second by the liquid moving, that is leaving the tube at a point B is W2. That means P2 A2 and V2. The net work done by the liquid in passing from A to B is equal to W is equal to W1 minus W2. Already we are having the value for W1, that is P1 A1 V1. Already we are having the value for W2 also. So that is P2 A2 and V2. Finally I have P1 A1 V1 minus P2 A2 and V2. So according to the equation of continuity, that means A2 V2 is equal to A1 V1. This is the equation of continuity. So I can change the above equation into W is equal to P1 minus P2 into A1 V1. So instead of I'm having this A2 V2, instead of A2 V2 I can write A1 V1 according to the equation of continuity. So the work done on the liquid is used in changing its potential and kinetic energy. So decrease in potential energy and increase in kinetic energy. So now we are having the equation is decrease in potential energy is A1 V1 rho into G, that means H1 and minus H2. Then increase in kinetic energy half into A1 V1 into rho into V2 square minus V1 square. The total gain in the energy of the system when the liquid flows from A to B is half A1 V1 rho V2 square minus V1 square minus A1 V1 rho into G into H1 minus H2. Finally, I have P1 plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho into GH2. So rho plus half rho V square plus H into rho into G, it's a constant. So P by rho, that then it is divided by rho. Then and the above equation is divided by rho. Then we have P by rho plus half V square plus H into G is equal to constant. So P by rho into G plus V square by 2G plus H is equal to constant. Here P by rho into G is called the pressure head and V square by 2G is called the velocity head and H is called the gravitational head. The Bernoulli's theorem may be stated as follows, that is, when an incompressible non-viscous fluid flows in a line motion, the sum of the pressure head, velocity head and the gravitational head remains constant throughout its motion. That's all. We prove the Bernoulli's theorem. Thank you.